Hello, welcome to the 4911 CyberKnights software training series. This is session 3. Today we're going to talk about parameters and objects, but before we do that, let's review what we did in session 2. In session 2 we talked about primitives and loops, and with primitives we talked about their types, expressions and how those can evaluate two-way value, literals, operators, the precedence of those operators, mixing different types of primitives, and casting. Then we talked about variables, declaring them and assigning them, and then how to declare and assign them in the same place. String concatenation, which is combining strings into a bigger string. Incrementing, decrementing, mixing types. And then we talked about the for loop, which was fun, and how to walk through a for loop or tracing. We introduced a new way to output text, which is system.out.print instead of println. And then we talked about nesting for loops, which is when things got wild and crazy. And then we wrapped up by going through managing complexity. We talked about scope, where things live, where they can be used and where they can't be used. A useful tool called pseudocode, decrementing a loop, where we start at a high number and go down, and how that can be useful in certain circumstances. And we also briefly talked about class constants. Today, we should have a shorter session. We're going to talk about parameters, methods that return values, and using objects. So right off the bat, let's talk about parameters. A parameter is just a set of characteristics that distinguish different members of a different family of tasks. That's a formal definition, but how you can think of it, it's the part that changes from one task to another. So you do a task twice, but you don't necessarily do it with the same inputs. The inputs that changed, those are your parameters. To parameterize something is to take a task and to find the things that are the parameters, the parts that change, and to make it a task that make it into a tool that you can reuse by varying certain things and keeping other things constant. All right, so here's an example. We have this class called spaces, and it's got a main method. We're familiar with that. The main method calls a method called write spaces. So if we look at the code for write spaces, it just has a simple for loop, which we've been using. We're familiar with this. We start at I, and as long as I is less than or equal to 10, we execute the body of this for loop. After each time we execute, we increment by 1. And all we do is we print out spaces. So since we go from 1 to 10, we're going to print 10 spaces. And at the end, they're all going to be on the same line because we're using print. At the end, we do a println. This is outside the body of the for loop. So we'll have 10 spaces, and then we'll start a new line. And my question is, what if we wanted to change the number of spaces? What if we wanted to parameterize the write spaces method? Well, what we should do is try making the number of spaces a variable. So we've worked with variables. We know how it works. Int number equals 10. We'll just read from that number variable inside the write spaces method. So instead of going from I less than or equal to 10, we're referring to our variable now, which we set at 10, and we can change it to 20, 30, whatever we want. The problem with that, though, is that this is illegal. And the reason why is because of something we've already talked about. It's scope. The scope of this variable, since it's declared in the body of the main method, it ends at this curly brace. So it cannot be read within the write spaces method. So there's one good idea that's out the window. So what should we do? Well, we should give the method a parameter, and that's where parameters come in. So instead what we do is between these two parentheses, which we've been leaving empty up until now, we declare a variable, int number. And then we can refer to that variable in our for loop. This is just fine. This will compile and run. And now we can change the value that we assign to number and change the number of spaces that we're outputting. But the question now is, how do we call this now that it has a parameter? And the answer is that in the same place where you just previously had right spaces, left parenthesis, right parenthesis, now you put something between those parentheses. You put what you want that integer variable to be. So we want int number here to be 10, so we pass in the literal integer value 10. Now that this method is parameterized, we have to specify the parameters. So we can no longer have this situation where you can't go back to where we just say right spaces, left parenthesis, right parenthesis. This is now going to fail to compile. So anytime you add parameters to a method, you must also specify those values in the places where you call those methods. Some programming languages will do things like have default values, and that can be useful, but it's also a bit of complexity that we're not interested in right now. We can also, just like any other value, we can use an expression. So instead of just putting the literal number 10, we can put in an arithmetic expression, 4 times 12. That evaluates to an integer, and the type here for our parameter is integer, so that's fine. We can do more complex arithmetic. We can use a class constant since length is an integer. That's fine. That can work. Now, when you are declaring the type of the parameter, and this is where it can be a little bit confusing, you only need to do it at the method declaration. So at the same place where you have like the full public static void, name of your method, parameters, and then the curly braces, that's where you specify the type. You don't need to specify the type when you're calling the method. You just have to pass in the value itself. And this can be a little bit confusing because, well, it just looks the same, right spaces and right spaces. Why wouldn't you put the int in front? And the answer is that it already knows what the type is. You've declared it in one place. We don't need to declare the variable in multiple places. So parameters have limitations, and one of the big limitations is that you can't get values from a method parameter, which seems like it would be a really useful thing to do. It seems like you would want to like maybe pass in a number, modify it, and then read it again. I'll show you an attempt to do that and explain why it doesn't work. So in this same spaces class, we've now modified the main method. We set the integer number to a value of 17 initially. Then we print it out, we call double it, and then we print it out again. And let's look inside the body of double it. We just take the number and we execute this line, and this line here, we've seen this operator before, the times equals. That just means that it's going to take the number, multiply it by 2, and then reassign it to that variable. So after this line executes, whatever we've passed in is going to be doubled. So if the number is 17, then number should be 34 after this line executes. So walking through the code, what you might expect it to do is we start at 17, and then we print start number equals 17, and then we go into double it. 17 gets doubled, and then it says double number equals 34, and then we go back to this line. Well, number has been doubled, so it should say final number equals 34, but it doesn't. If you actually run this code, it'll say final number equals 17. And the reason why this happens is because parameters are local to the scope of the method that they are declared in. So the values are copied into local variables. They're not just passed in, and this keeps the variables safe from modification. So going back to our example that we just looked at, these two variables, even though they have the same name, int number, they're actually different, and they live in different places. The scope of this int number is just within the main method. The scope of this int number, which has the same name, is just the write spaces method. So these are totally different variables. They're totally different scopes. They are totally different places in the memory of the computer. Writing to one does not write to the other. What happens when we call this code is we take the value that's stored at this number and we pass it in and we assign that value to this new variable also called number. So when we're executing, or anything we do to this variable is not affected, or does not happen to this one out here. Oh yeah, we can also have multiple variables. This is something that you're going to see and use and need a lot. You just there's just a general pattern. You just make sure to specify always the type first, the name second, and you separate them by a comma. And this is where naming the parameters becomes very important. You shouldn't just, if you have a bunch of parameters that are the same type, you shouldn't just call them like very slight variations of each other, like int number 1, int number 2, int number 3. That doesn't communicate to the person reading code what those mean. You have a bunch of, especially if you have a bunch of the same type, it should say something. The name of the parameter should say something about how it's going to be used, what it represents. And also, you have to call in the same order that they're declared in the method. So even though there's a character and an integer, you can't reverse the order when you call the method. You may think that Java would be smart enough to figure, well, it needs a character and an integer. Why doesn't it just, if I pass in one number and one integer and one character, why can't it just figure out, well, one is one and one is the other, just use them? It's not that smart. It's going to always try to use them in the order that you passed in. So if you swap these two, it's going to be upset that you're trying to send in an integer where it wants a character. You can now, and this is where things can be also, it can be confusing, but it's also incredibly powerful and useful. You can reuse method names. So we said before that like names are unique. Method names, you can actually reuse them, but the signature needs to be different. We need to have different parameters. So we can have a write spaces method that defaults, going back to our very first example, that defaults to maybe 10 spaces. And then we can have a different write spaces method where we allow the user to pass in a number and we use that number of spaces. This is totally fine. And you can have as many copies of that method as long as each one has a unique combination of parameters. Don't abuse this. The signature, which I've casually referenced before, I should define it formally now. It's the name of the method along with its number and type of parameters. So in this case, we have two different method signatures. They have the same name, but the parameter count is different. The parameter types are different. So they have unique signatures even though they have the same name. Method overloading is what we've done on the previous slide. It's the ability to define two or more different methods with the same name as long as they have different method signatures. Okay, so on to our next principle. I mentioned before that you cannot use parameters to get a value out of a method. Well, all is not lost. You can get something out of a method. It's just a totally different mechanism, and that is called returning. To return something is to send a value out as a result of a method. And then that can be used as an expression in your program. You can just assign it to a variable and reuse it later. Void methods, which we've seen a lot of up until now. In fact, I think maybe all the methods I've shown you have been void methods. That just means nothing. They don't return anything at all. So if you don't need to return a value to the person who called it, then your method should be void. And if you are planning on giving something back to the caller, then your method should have a return value. And here's how they work. Well, actually, sorry. Methods that return nothing are super easy to identify. You just look for the word void, and that word void will be replaced by something else if it has a different return type. You have to declare the return type in the method signature, and then the return value you'll do in the method body. Now, in this example, in the previous example, we have just our signature for write spaces. In this example, we have a method called sqrt, which is just short for square root. And if you're trying to take the square root of a number, then the return type should also be a number, and it might be a decimal number. And we know that for decimal numbers, we use the type double. And so our return type, even before we've written this method, we know that our return type is going to be a double. And we also know that if we want to take the square root of a number, we should allow the user to pass in that number as a parameter, and that number should be a double. We can take the square roots of decimals. Java has a built-in math class. All right, so writing a square root method is not all that useful because, as I mentioned a long time ago, well, I guess it feels like a long time, in session 1, Java has this powerful built-in set of libraries and utilities that you're free to use. So you don't need to write a square root method. That's built into Java itself. And there's a lot of other things that are built in as well. And one of the very powerful things that it has is the math class. And that's it has a bunch of very common math operations, and it has a few constants like pi, so you don't need to declare those. You don't need to like reinvent the wheel. You may in writing a method that does some complex math, you might make a very subtle and easy to miss mistake that you wouldn't have to worry about if you just use Java's built-in math classes, because they've been used and abused by lots of people. They've worked out a lot of the bugs that you might accidentally write into your own versions. All right, so let's look at our method here. And our main method, we just go from 1 to 20 in our for loop, incrementing by 1 each time. And then we print out the square root. This is our string concatenation syntax of I. And then we call the built-in Java square root method. And when you're calling a method from another class, if it's a static method, which square root is, you need to specify the class first, that's the math class, dot method name. If we were trying to use like pi, it would be math.pi, and that's not a method, that's just a value. So we wouldn't need the parentheses or to have a parameter. Speaking of pi, there's constants built into the Java math class. Two of the most commonly used ones are going to be e, which is the base used in natural logarithms, that 2.71 value that has a very long decimal. And then pi, everyone's familiar with pi. You don't need to look it up and copy it into your code. Just call Java's math.pi. In Java's math class, there are a bunch of methods that are really useful. Here's a few of them. There's a lot more. These are pretty straightforward. ABS is just absolute value. If you pass something in, it's going to do the mathematical absolute value. Ceil is short for ceiling. It's going to round up. You remember how we talked about how mod will just take or not mod, but integer division will just cut off the end. Well, if you want to like round something up, this is one way to do it. COS is cosine from trigonometry. EXP is exponent base E, that constant that we talked about in the previous slide. Floor is opposite of ceiling. Log is logarithm base E, log 10. The last two are actually really useful. Max and min you can pass in two values, and it will into the max or min methods, and it will return the maximum or minimum respectively. So in like your code that you're writing, you may be reading from two different sensors on the robot, and you want to know which one's higher or which one's lower. You don't have to compare them. You can just call math.max or math.min, and it'll give you the higher or lower value, whichever one you want. There's also a POW, which is a power. You can raise something to the power of another number. It takes two parameters. Random, it gives you a random value, but you should read the documentation on that one. So there's some tricky gotchas. SIN is sign. We've already talked about SQRT for taking square root. We also have these two very handy conversion methods, 2 degrees, where we take an angle that's in radians and we convert it to 2 degrees. And then conversely, there's 2 radians, which will take degrees and convert it to radians. And that's really useful because some sensors or some libraries may prefer degrees, or maybe degrees are easier to read for the user if you're trying to show it on a dashboard. But radians are going to be maybe preferred by some libraries or controllers. And you need to remember to convert between the two and not just use one as the other. If you're really curious, you can check the Java API documentation, and you can just Google that, Java API documentation math, add math to that Google search, and you should find the page for the math class, and you can read through the whole thing. So we've already said that when you have a method that needs to return something, that we need to specify that its type is in the signature of the method. Now, at the moment when you want to return something to the person who called it, you need to use the Java keyword return. And this is why you can't name a method return. This is a reserved, very important keyword. Anything that is to the right of return will be evaluated to a single value and then returned back to the person who called your method. Don't ignore the return value when you call a method. So going back to our previous example, if we have a feet variable that we pass into this miles method, and we are using 15,000 feet, this isn't going to do anything because we've just called the method and ignored the return value. So it does the execution. Whoops. So it does the execution, and it calculates the actual equivalent in miles, but then we just throw it away. So yeah, don't do that. Instead, you should declare a variable, or maybe you have one that's already declared, and then you assign it the return value of your method that you've called. And this is how you would just do it. You use the regular assignment operator, and you put your method call to the right of that assignment. If you don't want to assign the variable, sometimes you don't really even need to. You can actually just call the method in the place where you're going to be consuming that value. So in this string concatenation, you can actually just call the method directly. You don't need to declare a variable to do this. So yeah, an important warning about accidentally putting statements after a return. Return means it's over, it's done. You can't do stuff after returning. There are places like you return, or we'll get to this eventually, but you can have multiple places in a method that return different things, but that's sort of a different point. After you've returned something, there can be no more execution. So that means that in this example here where we're returning a distance and then we're printing it, this is not going to work. Java's actually going to complain about this and it won't compile. Instead, what we could do instead of this is printing it out. We just swap these two lines here and this would be totally fine. Print it out and then return it. Okay, so now moving on to objects. Objects this is where things get a little tricky. It's a programming entity that contains data and behavior, and the two different things there, data and behavior are sort of married together within the object. You'll have data that object that's related to that object, that's logically related, and then behavior stuff you want to do to the data. These are more complex than what we've dealt with up until this point, those primitives. That's why we call primitives primitive, because they're not as complex as objects. And a class, which up until this point we've used class a lot, and we kind of give a partial explanation. A class is, up until this point, it's just been like a container for code, like everything has to live in a class. Well, a class is actually broader than that. Yes, it's a container for code, but it's also a category of an object. So an object has a type, and the type is defined by the class. In a lot of definitions, they say that a class is a blueprint for making an object, and that the objects are the things that are built according to the blueprints. And now, unfortunately, for historical reasons, the syntax, which is just a very formal way of saying the way we talk to and deal with objects, is different than the way we talk to and deal with primitives. And it's just something we have to learn and work around. It's a little frustrating, but you'll get used to it, and then it'll be second nature. We have actually already seen and used objects this whole time. I've tricked you. I've kind of hid it away. We've been using a certain type of objects, which are a little special, and those objects are strings. Strings are actually objects in Java. They are not this simple primitives, not like an integer. Strings are more complex, and they're one of the most used objects in Java. And they actually have their own special syntax because they're little special snowflakes. This was just a decision made by the creators of Java because strings are so commonly used that for convenience they gave it a little bit of a special syntax that's different than other objects. And two of those most important things are that we have string literal syntax and string concatenation syntax. So the string literals are just when we create a string. So first of all, one of the things I want to point out here is the type. So int height, we know an int is, it's an integer. The type is int. And then string color, we know what a string is. It's a string of characters, and string is the type here. So these are both types, int and string. And if you notice, the first letter of string is capitalized, and the first letter of int is not. String types always have uppercase letters at their beginning. They're always capitalized. And then primitive types are always lowercase. That's just for the types. When we get to the names are still lowercase for both primitives and for objects, and also for methods we use lowercase names. But this literal syntax that we use for strings is just what we've seen all along, where we have the double quotes and stuff in between. This actually is creating a new object, and then this assignment operator assigns it to the variable called color. And then string concatenation, this is actually this line down here where it says color plus a string that just has a space in it, plus a string that has the word raspberry into it. This is combining those three strings. It takes all three of them and concatenates them end to end into one new long string that it then stores in the variable flavor. Although it's not quite storing it there, but we'll get to that. Objects have their own methods, and I said in a previous session that static, when we have methods that say static in their name, that just means they are not object-oriented, and then I didn't define object-oriented. Well, now's the time. Object-oriented means that it belongs to an object. It deals with objects. So when a string has a method, that's an object-oriented method. Object methods belong to a single object, whereas methods that say static, they belong to the class. And so static methods can be used anywhere. They can be used inside the class. They can be used outside the class. And we saw that with the math class. It has static methods that you can call by calling math.abs, math.max. Those are static methods. If you have an object method, you cannot call it using the class's name because it belongs to a certain object. You have to say which object. Like, what object are you talking about? You have to refer to the name of the object and then the method name. And that's where we see the syntax down here. Flavor, which is a single object, not the class string, dot length, that's the method name, and then we give in parameters. Length doesn't take parameters, so it's just empty. So that's the syntax for calling a method that is an object method. It's similar to calling a static method. It'll look very similar, except that the thing that we're, the part that comes before the method name is an object name, so it's always going to be lowercase. And then if it's a static one, it's going to be the class name, so it'll be uppercase. And that's a quick way of identifying if you're looking through code. All right, so yeah, do not forget, on that note, do not forget the object's name when you're calling that method, when you're calling an object method. So if I wanted to know, like, what's the length of a string? Well, and I just call length, well, what object are you referring to? Like, do I mean, what is the length of the color string that has 4 letters blue, or the label string, which has more letters? I'm not going to count them right now. And that's why you have to use the previous slide syntax, where you say the object name and then the method. Okay, so if you want to get the length of a string, and we've been using this method previously before we've actually defined it. Strings have, or the string class has defined a method, or an object method called length that you can use to get the length of a string. And it's just the word length, and since it takes no parameters, you just have the left parenthesis and the right parenthesis when you call it here. So yeah, that's how you get the length of a string. Now, we should talk about indexing with Java. For legacy purposes, and I know I say that a lot, the index, or Java uses a different indexing system. And an index is just like where something is in a sequence of values. So like a string has a bunch of characters, and you want to know maybe the character at a certain position. In English, if you wanted the 4th character, you'd say, well, the character number 4 of that string. And everyone would know what you're talking about. But Java uses zero-based indexing because things that came before it also used zero-based indexing. And that means that the first item has an index of 0, and then it counts up from there. So looking at this hello string right here, the first letter H is going to have an index of 0. E is 1. L, or the first L is 2. The second L is 3. And then the O is 4. This is something that you'll just get used to over time. And then here we just have a longer string. If you count out the number of characters here, you'll see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and then the question mark makes 12. This string has 12 characters in it, and the index of the last character is 11. And that's just something that happens with strings and other data types that we'll get to eventually. The last index is going to be the size minus 1, or 1 less than the size. If you want to get the character at a certain spot in a string, there's a method that's declared, or that's been defined for that within the string class. It's an object method, and this one actually takes a parameter, unlike length. It's going to take as a parameter the index of the string, of the character that you want within that string, and it's going to return the character that's at that index. And so we have an example piece of code here where we start at 0, and our for loops up until now have been starting at 1 mostly. But we're going to start at 0 now because strings have a 0 as the index of their first character. And then we're going to go up to the length, but we're going to to say less than length. So we want to stop just shy or 1 minus, 1 below the actual length. And then we just print out the character at each index. And you'll see this sort of pattern a lot in your programming, where you start at 0 and you go up until just less than the length of the data that you're dealing with, so that you don't go past the end of it. If you want to get part of a string, there's another method that's defined for that. It's substring, and it follows that syntax, that camel case naming that we've seen. It's a method, so it starts with lowercase, but since it's 2 words, substring, the second word is capitalized just so it's easier to read. And it takes 2 parameters instead of just 1. The first parameter is the starting index, so it's the character that you want to start at. And then the second, this is where things get a little weird, the second parameter is the ending index, which is the position like right after the last character that you want. Not the last character you want, it's one more. And an annoying implication here is that if you want the very last part of a string, you can see that the last index here is 11 because there's 12 characters here. So if you wanted this U, then you would start at the index 8 and you would end at the index 12, even though the index 12 doesn't exist. That's just how things work. And as I said before, it returns a string. And you can see a couple of examples here, 0, 5. So it's going to start at 0, which is the H, 1, 2, 3, or it's going to go 0, 1, 2, 3, 4, 5. And the reason why the comma is not included is because the second index is right after the last character we want, which is the O in hello, and that's why we get hello. It's okay to say 15 to 19, even though 19 is just beyond the end. It's after the index of the question mark, which is index of 18. So this is fine. But what happens if we pass in a bad index? So what if we try to say 20? 20 is 2 past the question mark. So that's actually going to be an error. What happens if we do something really ridiculous and we try to say -1? What if we try to go to -1? Well, that's also going to be an error. And it's important for us, I think, right now to define these errors, which are exceptions. Exceptions are errors that happen while the code is running, not while it's compiling. It's after it's compiled and you're running. And it's an error that stops the program from running normally. When that error happens, the terminology that we use is that the exception is thrown. So the code, when it gets to a place where there's one of these errors, it throws an exception. And the reason why I call it that is because you can actually catch exceptions and deal with the error, maybe try to fix it, but we'll get to that later. For now, it's just when you hear someone say throw an exception or an exception was thrown, it just means an error happened. And this is what it would look like if you were looking at the output. And the name of the exception is actually really helpful. String index out of bounds exception. Well, yeah, our index was out of bounds in both cases. And it'll actually sometimes give you even more details. String index out of range is -1. Well, yeah, -1 is definitely out of range. If the first character is 0, we can't go backwards. So when you get these errors, some of this is gibberish, or at least will be gibberish until you have more experience, but the first line, just the name of the exception and maybe the message itself, might give you a hint as to what's going on. We talked about some static methods that live in the math class. Here are some object methods that live on the string class. And these are all methods that you may come across and may want to use. We have char at or character at. We've already talked about that one. Ends with is actually checking whether or not a string ends with a certain piece of text. So for the word hello, if you were to say, does it end with LLO? Well, yeah, it does, so it'll return true. index of, it returns the index of a character or a string. So the text that you pass in could be a single character or a series of characters. And you can see, like in our example, if we check for the index of O, the letter O, it's going to return 4 because it's the fourth, or the 0, 1, 2, 3, 4. That's the index of the O. If it's not in there, it'll return -1. That's -1 is a common return value for not found, or even an error. Length, we've talked about length. We know what that means. A starts with is just like ends with, but the other end of the string. Substring, we've talked about that. And then there's these two interesting methods that we'll talk about that have some important gotchas. So there's 2 lowercase and 2 uppercase, and they do exactly what you'd expect. So if you try to convert HELLO to lowercase, well, look, it's the same thing because it already was lowercase. But if you call .to uppercase, it'll return HELLO in all uppercase letters. No surprise there. But this kind of raises an important thing to talk about, an important issue, and that is the idea of immutability, or an immutable object. So mute is like mutable, it's like mutation, changeable, but an immutable object is something that cannot be changed, that cannot be mutated. Once it's created, it can't be modified. And so strings are actually immutable objects in Java, which is actually really the right thing to do. There are strings in other languages that are mutable, and that flexibility allows you to do some things and gives you some advantages, but it also leads to some really surprising and fun, and by fun I mean like headache-inducing errors. So if that's true, if you can't modify a string, then how in the heck does to uppercase work? Like I just said, it takes the string and converts it to uppercase. If I can't change the string, then what's going on? Well, the answer is that those methods return new strings. They don't change the string itself. So if you look at this code here, string greeting equals hello, comma, Sally, and then you convert it to uppercase. If you call greeting dot uppercase and then you print it out, you're actually just going to get this exact same string here with only the first letters of each word capitalized, not the whole thing, because to uppercase returns this string converted, and you haven't done anything with the return value. You just called it and you didn't assign it to anything here to the left. You just threw it away. So yeah, you're just going to print out the original unmodified greeting. So this code here at the bottom, where we declare the variable and then we assign hello Sally, that's the same. But here's the key difference here. We call greeting.to uppercase, but then we assign it back to that same variable, and then we print it out. This code will do the stuff that, or the thing that you're expecting here. It'll completely convert that string to all uppercase letters. All right, so that's sort of a rough idea of how string objects work. But like I said, strings have a little, have some special syntax that is useful for dealing with them, and because they're so common. Other objects have a lot of very similar syntax, but there's some important key differences. And so to identify these key differences, we're going to take a look at this type of object called a point object. So there's a class called point. We're not actually going to use this class for practical purposes. We're just going to use it to learn, and then later on we'll deal with some other classes that are actually going to be more practical. So yeah, a point object is a class that's built into the Java libraries, and it's meant to represent a point, just like in mathematics, in 2D space, like Cartesian coordinates. Unlike strings, it must be created via a constructor. So what's a constructor? I haven't told you what that is yet, so it's not fair for me to ask what a constructor is. I'll tell you what it is. A constructor, it's a special method on a class that creates the object and initializes it. And now objects always have to be created before you can use them. That seems like maybe obvious, but it's an important distinction. You can't use an object until after you've created it. And that creation step happens in the constructor. When you're defining a constructor method, it always has the same name as the class. And so I've set up until now that methods should be lowercase. Well, not constructors. Because the class name is capitalized, the constructor method should also be capitalized. And this helps you to identify which method is the constructor and which ones are not. You have to use the special keyword when you're calling the constructor method, and that keyword is new, N-E-W. It's a reserved Java keyword. You can't use it in your own like method names. New is just particularly reserved for creating new objects. And so the syntax is going to be what we see here, where we have the type and the name. That's not new. And then this assignment operator here. But this is new. The word new is new. And then we invoke the method, point method. And we can't refer to the name of an object yet because it doesn't exist. We have to create it. So this isn't like new p.point. We have to create it before we can call those object methods. So the syntax is a little different. So new point, and then just like other methods, they can have parameters. If there are parameters in the constructor, you got to pass them in. So point has two parameters, x and y. We're going to pass in 5 and 17. And then what can you do with objects? Well, one of the simplest and quick and dirty things that you can do with an object is just to print it out to see what happens. And very often you'll get some useful information. It might look like a little gibberishy. So this is java.awt.point. Okay, we recognize point and we kind of know what Java means. And then x equals 5, y equals 17. Oh, those are the things that we pass into the constructor. So yeah, printing out an object will very often include values that are inside of that object that you may have passed in through the constructor. So here's what a complete usage of the point class would look like within your own code. So we have a class called test here and a main method. We create a new point just like we did on the previous slide. We print it out. And then point has this special object method. So we use the regular object method syntax where we refer to the object by name, dot, method name, and then we pass in the parameters. So translate, if you were to look up the documentation for the point class, will tell you that it just moves it that many places. So we're going to translate it -10 in the x direction and -10 in the y direction, and then print it out again. And if you look at the output, we have what we would expect, 5 and 17, and then -5 and 7, because we've translated by -10. All right, so I guess I should point out on this particular slide, I talked about it before, the java.awt.point, and I kind of skipped over it and didn't say what we were doing here. Import java.awt.point. Well, what is that? That's a package. A package is like, it's a way of organizing code. So when you are using various classes, they're not just all dumped into the same place. They're organized into like a series of folders conceptually. And it'll be like in a folder with other related things. So graphics are going to be in one folder, math stuff is going to be in another folder, so on and so forth. And the point class lives inside this java.awt package. We don't need to know what that stands for, we just know that's where it is. And if you want to use something that lives somewhere else, if it's in your package, you don't have to import it. But if it lives in another package, then you have to use an import declaration, which is just a request to Java to say, look, I want to use this thing over here. Please import it into my code. And the syntax is just what we saw on the previous slide, import java.awt.point. And once that is there, then you can use the point class. There are some classes like string. You don't need to import string. Java just says, you're probably going to use it. It's there. Go ahead. All right. So now we should talk about an important concept called references. So let's go back to when we declare and initialize a primitive value. So we have int x equals 5. We know exactly what that means. Integer is the type, x is the name, 5 is the value. And what happens when we have that statement is that a chunk of memory gets reserved and it gets assigned the label x. And so no one else can overwrite that memory. Only we can say what happens to that memory. And then the equals 5 writes the value 5 into that slot in memory that has the label x. Now, the syntax for creating a point or an object, as we've already gone over, is a little similar, a little different. We still have the type, the name, the assignment, but then the special stuff. New, and then constructor, and then parameters. What happens here is a little different. We have a chunk of memory that's set aside, and the label is the variable name p, but it contains, instead of containing the entire point, it actually contains a reference, which is an address of the place where the object actually lives. So the subtle distinction here is that this x is the value itself. The value lives in the place that is labeled x. But the point lives somewhere else in memory. The label or the label p refers to a place that points to the actual object. And the reason why this is an important thing to understand is that you can kind of shoot yourself in the foot because it's semantically different. And semantics is just like in language class where you learn about the way that you talk, the way that you write, the way that you address things. That's the same thing in programming. It's a language, so the semantics, the way that we talk about things is different for primitives as it is for objects. And the way that we talk to primitives is called value semantics. So it's a system where the values are stored directly in the place that you are defining. And so when you copy them, it duplicates the values and stores them. So if we have these two variables, integer or int x equals 5 and then int y equals x, y is 5 and x are 5. However, they're not the same number. They're not referring to the same place in memory. They're different things that are copied to different places in memory. If we increment x like this, we use that increment operator, x becomes 6 because we've increased it by 1, but y is still 5 because those are copied values. They're not the same. Reference semantics are different. So the values are stored indirectly. This is, as I said, this variable refers to an address where the point actually lives. And so when you copy something, you're duplicating the references. You're not duplicating the actual values. So point p1 equals new point. Point p2 equals p1. What this actually does is it creates two references to the same point. And so if we translate -1, -1, P1 and P2 are both now 4 and 4 because they're both the same point. Anything you do to P, oh, that should have been P1, not P. Anything you do to P1 will modify P2, and anything you do to P2 will modify P1 because they are both just addresses for the same thing, the exact same object that there is actually only one of. It has not been copied, just the references have been copied. All right, so how do we deal with multiple objects? So, well, we just have to declare them multiply, or in multiple instances. So each constructor call creates a new object. If you want a new object, you gotta call the constructor. Assigning to an object variable doesn't create a new object, as we saw in the previous slide. You can assign to a new object variable without creating a new object. It's an old object. If you want to create a new object, you gotta call new constructor, pass in parameters. So let's look at this code. We create one point, we assign it to an address that has the label P1, and then we create another point and we assign it to an address that has the label P2. And now, if we say P2 equals P1, what have we done? Well, what we've done is we now updated this address to now, instead of pointing at this object, it points to the object that was at P1, which is now this object. So we're back to the place where we have two references to the same object, and this object has no references at all. We have not created a new object. We've only updated the address of one of them to point to another one. So it's two references, one object. I'm speaking slowly because this is something that really tripped me up when I was first learning it. When you're dealing with value parameters, and we've already covered this on a previous slide, if you are, well, let's just look at this code. So there's a main method and there's a modify method, and we can see in the main method we create a variable called x, we assign the value 4 to that variable, and then we call the method called modify with that variable. And in the body of modify, we take that variable, we add 5 to it, and we reassign it back to the variable. So after modify is called, because x started at 4 and we add 5 to it and reassign it back to x is now 9. But that doesn't change this x here. This is a different variable. The scope is different. And remember, when we copy values, like when we pass this x in here, it's actually copying that value. It's creating a duplicate, and a duplicate variable called x that also has the value 4 in it. There's no relation between this one and that one, other than that the initial value here comes from what was assigned here. Anything we do to x within the body of modify does not affect the x outside the body of modify. And so after modify is called, x in the main method is still just 4. Now this is a different situation than what happens with object parameters, because object parameters are references. So they're addresses that point to the place in memory where that object lives. So looking at a similar piece of code here where we create an object, a point object. So the type is point, the name is p, we create 2, 5, so x is 2, y is 5, and then we call the modify method, and in modify we add 1 to each value by using the translate method, which we've already talked about. So after this method is called, the p in modify has been translated by 1. So it's been translated to, so it's been translated by 1 and 1. So 2 becomes 3 and 5 becomes 6. And the p back here has also been updated to 3 and 6. Now that isn't because it's duplicated that point in 2 different places. This reference that gets passed in is a reference to the same object. So even though this p and this p are different, they're just different references. They're different references to the same object. So anything that you do down here goes through this reference and affects this object, which this reference still points to. So I hope that's clear. I hope that makes sense. Okay, so anyways, thank you so much for taking the time. I am pre-recording this because it's a holiday weekend or holiday week, and I just wanted to make it more convenient for people to watch it at their leisure. If you have any questions, I guess hit me up on Slack, or if you wanted to ask them publicly, I suppose you could put them in the comments, but I may not notice those as quickly. Anyways, thank you, and stay tuned for session 4.